Hey guys, this is Vivek, and today in this video I will be discussing with you a very important concept of system design, which is cap theorem. Cap theorem is very plays very crucial role in deciding some of the important factors while designing distributed system. I will explain you first of all what is cap theorem, and after that I will also discuss with you some of the use cases or real world examples of how this theorem can be used to take some business decisions. Let's start. In the word cap, I mean in the acronym cap, there are three letters: C, we have A, and we have P. In the acronym CAP, C stands for consistency. Then A stands for availability. And P stands for partition tolerance. Okay, so what does Cap's theorem says that in a distributed system we can achieve any of the two properties out of these three. So we might have certain distributed system which might be consisting of load balancer. Then there might be multiple machines behind our load balancer. So let's say these are the machines that we have behind the load balancer. There might be certain databases behind these servers. There might be replicas, there might be multiple nodes of database bases, and these servers might be interacting with these databases. So so uh, in in such kind of distributed system, a cap theorem comes into picture. So I will first of all explain you what consistency is, what is availability, and what is partition tolerance. First of all, consistency is every read request should get the latest fresh write. What does this mean? That, for example, if multiple nodes are writing to these databases, so let's say any server makes some write to any of the DB replica. Then if any node is calling that same resource from any other node, that server should get the latest write that this machine did, or this machine did, or any of the machine did. So that is what consistency is like. Every read request should get the latest write. Next is availability. What does availability says? Basically the availability says that like every request should get a response. So that response might be stale, or that response might not be the correct one or the latest one, but every read request should get a response. That is what availability is. So it basically suggests that the server is up and we are getting the data. So this is something called as availability. And partition tolerance is like our system is up and running even in case of network failure. So let's say we might have different machines in the production. So there might be some network failure or breakage in the system, but partition tolerance ensures that our system is up and running even if there are network failure or any node fails or the system become any of the machine become isolated. So that is what partition tolerance is. So let me move to the next slide to explain it in more detail. Okay. So so first thing is, we as I discussed earlier, we might have any of the two, like in a distributed system any of the two is guaranteed out of CAP. So first of all, we might have consistency and partition tolerance. Then we might get consistency and uh, availability, and third one is uh, availability and partition tolerance. So let me one by one explain you what these three means and how they are used. So first of all, we have consistency and partition tolerance. So it means that uh, our system might not be available sometime, but our system is strongly consistent and partition tolerance. So this kind of requirement is there for any banking application. Banking application is the best example for this. Okay, so here we might have to compromise with the availability. For example, if you have ever experienced this, like in some of the banking application, we might not get the response, but in those kind of scenarios, consistency is very important and partition tolerance is very important, because because banking application has to ensure strong acid compliant properties, and they have to ensure strong consistency. So that's why these two are necessary. Okay, so next I will first of all consider this one, availability and partition tolerance. So this the example for this is, we can say, social media feed. Okay, so just like we have Instagram, Facebook. So what happens there, like the system is this kind of systems are highly scalable with millions and billions of users and large number of requests coming per second and coming per minute. So this system, in this kind of system, we can compromise with consistency, but availability and partition tolerance is something which has a huge importance in these kind of systems. For example, let's say a user has a huge, let's say there is one celebrity who has his account on Instagram, let's say, and he has huge number of followers. So here what might happen, whenever he put some post onto the Instagram, some users might not see his latest post once they visit the profile of that users. So it, we can say that in other way, it might not be the consistent, but it will never happen that any user tried to visit the profile of that celebrity, and the page itself is not getting loaded or the response itself is not coming. So that is something called as availability. So availability is always guaranteed in this kind of social media apps, and partition tolerance is definitely there. So whenever we consider real world application, partition tolerance is something which is always considered. So we just have to choose between the consistency and availability based on our business requirement and business logic. And the third one which is remaining is consistency and availability. So generally since we don't compromise with partition tolerance, this kind of system rarely exist. But Yeah, for just to give you an example of consistency and availability where partition tolerance is compromised, I can give you example like single node relational database, for example MySQL or any kind of SQL DB. Single node relational DB is one of the example for this. So this was about consistency and availability. To explain it more better to you, I will draw one diagram and explain this theorem with the help of that diagram that you can also use. Okay. So here we have consistency and availability. We have consistency and partition tolerance, and we have availability and partition tolerance. Okay, so either we might get this, we might get this, and we might achieve this, but we can never achieve this one. This one never can be achieved. So this is something called as cap theorem. So I hope you understand what cap theorem is and its some of the use cases. So if you like this video and if you are able to understand, please hit like to this video and subscribe my YouTube channel, and you can also let me know if you have any doubts. In future I am also planning to bring out some of the more videos on system design, multi-threading, concurrency and parallelism. So stay in touch with me. You can also follow me on Instagram and Facebook, not Facebook, sorry, you can also follow me on LinkedIn. So thank you. Bye.